This challenge will be converting RGB into hex. The only valid numbers for RGB are between 0 and 255. In this example, we have 255 3 times and we get back 6 Fs. And even if we step outside the range, we still get the Fs in the last digits. Before we can write any code, we first need to understand how to go from RGB to hex. So how this works is you have 6 characters, which is equal to 3 pairs. The first 2 Fs is the first number, and the second one is the second number, and the third is the third one. So we have 3 pairs here, and let's break down the first one. We have 2 Fs, and that equals to 255. And the way this is calculated is the first number going from right to left. This is 1 times something, and this is 16 times something. Because they're in 2 columns, and it goes up by 16 times. So because this is 1 times, and then 1 times 16 is 16. So this is a multiplier of 16, and this is a multiplier of 1. And what you got to understand is with binary you only have 1s and 0s, but with hexadecimal you can have from 1 all the way to 15. But because 15 is actually 2 characters, and if you wrote 15 like this, then it'd span across 2 columns. So the reason why you can't have 15 is because it literally has more than 1 character. So then what we have in hexadecimal is we have 0 to 9 because that's contained in 1 character, and then we have 10 to 15 is actually represented as A to F. So what this actually reads is 15, 15. And because I said the first column is 1 times and the second column is 16 times, then what we can do is have 15 times by 16, and we can add that to 15 times by 1. And that equals to 240, 15 times 16, and 15 times 1 is just 15. So if you add them all together, we actually get 255. So let's take another example. So if we have D3 down here, we can take the D3. D is our 4th letter. So A is 10, B is 11, C is 12, and D is 13. So we have 13 times by 16, and then we're adding that onto 3 times by 1 because the first column is 3. So that's going to be 208 plus our 3, which gives us 211, as it says here. So that's how we go from hex to RGB, but when we actually write our function, we then get given 3 values, an int R, a G, and a B, and we actually need to go the other way around. So let's see how we can reverse this. So if we start off with 255, and let's see what we can do. So if you remember from my tutorial series, if you divide 2 integer numbers, then you get an integer back. And then we can also use the percentage operator, which will give us the remainder. So we need to find the values in hex from biggest to lowest. So we need to find first how many times this will go into 16, and then we need to find what's left over, and that will give us the 2 columns. So the first calculation could be 255 divided by 16, which will give us 15 point something. And because we're going to be using integer division, it'll get rid of that point something and leave us back with 15. And then somewhere in our code we'll have to convert that into an F because it passes over 2 characters. And now the next operation is finding out the remainder. So if we do 255 modulus 16, that's also going to be equal to 15. Because the closest multiple of 255 to 16 is 240. And from 240 to 255 is we have 15. So now we take the value from these 2 calculations and then allocate them together, which will just give us our FF. Therefore we got the 2 Fs inside the brackets. Awesome, so let's get started in the code. So let's leave these comments there just so we can refer back to them. We can get rid of this return null. Because we have 3 integer parameters, we need to process the calculations on each one of them. So for now, what we can just do, because we don't have the system library imported, we could just say using system, just so we have to type in console.writeLine instead of system.console.writeLine. And let's see what we can do in here. So we can have a console writeLine, and let's process these 2 calculations. So let's start with int R first. So we can have R divided by 16, and have another console writeLine, R modulus 16. And let's just do return empty quotes, because our function does return back a string, and if we don't have something as a return value, we're going to get a syntax error. So let's run that code. So as you can see, we have 2 15s, which actually match up exactly with what we've wrote above here. The first one is going to do an integer division. If I actually convert this into a double, and convert this into a double as well, so we can say convert to double, and wrap this around, and if we run this again, you can see that's actually the output, but we don't care about the remainder. We just care about the 15 as we said up here. So if we revert this back, So we've got r divided by 16 is 15, and the same thing for the modulus. So we have both of our values, and now we just need to put them together. But the issue here is we need to check these values using if statements, and if it's equal to 10, it's an A, if it's equal to 11, it's a B, and so on and so forth, all the way up to double F, and have console write lines just to output all the different values. So we have G divided by 16. I'm just going to forward this bit and write the rest. There we go, perfect. So we have two 15 pairs for each one, and it's processing the first one, so it's expecting all Fs, and as you can see, we have all 15s here. So after all of these calculations, we're going to get an integer number back. Maybe we can create a function that can take this integer parameter in and then return us back with a string. So we can have another public static string and then do return letter. And then we just need to take an integer parameter in. And then we can say if A equals to 10, then we can return a capital A and keep going on like this. If A is equal to 11, return back B. Else if A is equal to 12, return back C. Else if A is equal to 13, return D. Else if A is equal to 14, return E. Else if A is equal to 15, and then we can return F. And else, in case it doesn't fit into any of these, we could just simply return A.toString. If we don't include this last else, it's going to complain that there isn't a specific pattern left to fit all of the different roots to return back a variable. So now what we can do is actually use this function. So we can use return letter and all of these values, return letter, and just pass in this value. Add another bracket at the end, and then we can just use return letter in here and print it straight to the console. As they don't want you to cheat, you can't actually copy and paste in here, so I'm going to have to type these out manually. There we go. So now if we run the code, let's see what we get returned. Perfect, so now we get lots of Fs. This is exactly what we need, but we just need to now put them all into one string. It's going to be a long line, but what we can do just for the time being is see if we can do this. Return letter followed by r/16, and then without putting spaces between the curly braces, we can just keep chaining them like this. This is obviously going to get a little bit tedious. Let's just do the first two to make sure this pattern works. So now we should get two Fs returned back next to each other. There we go. So it got two Fs, but expected 6 of them. So we have them in console outputs, but we just need to put it in the return statement. Of course, we don't want to just string all 6 into here, so let's see if we can use a function. We can have a public static string, and maybe something like returnPair, and then use an int A again, and we can just return something quite simple. So inside our string interpolation, the values that we're going to use inside is we can actually call back the return letter inside here. So we can use return letter A divided by 16, then we can add return letter A modulus 16, and that should give us the values that we need. Add a semicolon at the end, and then what we can do now is instead of having two of these that do exactly the same thing, we can have returnPair and then simply just pass in our R. And let's chain these together now that the code's a lot smaller. G, and then finally the last one, returnPair B. There we go. Let's try and run this and see what happens. So we actually have passed some of them, but we have some range checking. So we passed the first one because now we've hit the 300, and it still expects an F because you want to round this down to 255 if it's over 255. Because it hasn't resulted in a fault here, then we know we've passed it. We can confirm this by just commenting out the other ones and just rerunning the tests. And let's do them one by one to make sure we're on target. There we go, so we fixed this one. Now if we just get rid of our returns and we don't need them anymore. There we go, so we're still passing okay. So the main problem with this next test is that the 300 is way over. This calculation is kind of correct. It's still doing the conversion, but it's in a completely wrong format than we need in the code. So what we need to do before we even get to this returnPair function, we actually need to make sure that R, G, and B all have values that are between 0 and 255. So essentially what we want to do is say if R is greater than 255, then R is equal to 255. And we can have an else if R is less than 0, then we can make R equal to 0. And we can essentially have the same thing for all of the different variables. But as you can see, it's going to get a little bit tedious, and at this point we should make a function. So we can have public static int restrict range. int a. And then let's bring this code down again because I can't copy and paste. Let's rewrite it. If a is greater than 255, then we return 255. Else if a is less than 0, then we return 0. And because we need a last path, we can just say return a. There we go. So now what we can do is we can say r is equal to restrict range and pass in the r variable inside the parentheses and do that for all of them. There we go. So if you run it, it should pass the second test now. There we go. So let's actually just bring them all back and see how many other ones that we do indeed fail. And we've actually passed them all. And the reason why is because we also have a negative value in here. And now that we've used a is less than 0 and we can return 0, then it'll just process this as a 0, and there you got 2 zeros printed here. So let's have a little look and see what different ways that we can use this code to make it slightly better. So if we don't want to have to do this notation where we have to say r equals the return value, then we can actually get rid of these and change this into a void, and then we can make this into a reference. So we can say ref int a, and then we can place ref before these variables here. And then instead of returning, we can just say a is equal to. And then because this no longer returns anything, we don't need this last path because it's not going to complain about it. Let's just make sure that this still works now. Yep, that's working fine. A couple other options that we can actually use is we can have an int array called numbers. We can say new int, and then we can give it the values of r, g, and b. And then we can have an overload on this function, public static void restrict range, and we can have it int array called a. Then we can use a for loop inside here. For int I equals 0, I is less than a dot length, I plus plus, and then we can copy the same code above. If a is greater than 255, but we're actually going to use the index now. A index is equal to 255, else if a index I is less than 0, then a index I is equal to 0. And we don't need the last path again because it doesn't return back anything from this for loop, and then we can just have return a at the end, and this will be returning back an integer array. So now what we can do instead of having these 3 lines, we can just simply say our numbers is equal to restrict range, and then we can pass our numbers in there. Perfect. So let's just give this a shot and see if it still works. First, before we do that, we need to change these variables. There's actually going to be numbers 0, this one's going to be numbers 1, and this one's going to be numbers 2. Now let's test it, and it still works fine. So now that we've made an integer array and passed them all in, I wonder what other ways we can use. And as you see here, we're just adding the value of 0, 1, and 2, so maybe we can actually put this inside a for loop. So we can have string output equals nothing, and then we can have a for loop int I equals 0, I is less than the length of our numbers array, I plus plus, and then inside here we can just say output plus equals because we want to append to it, and then we can use the return pair, and then numbers square bracket I. This is kind of what this output is doing right now. It's taking each of the array indexes and then just sticking them all together, which is the same as using plus equals. So now that that's actually ran, maybe we can comment this line out and actually just return output and see what happens. Let's run the tests and see if it works. There we go, it's still working fine. So now let's press the attempt button because this is going to use the full test suite. When you're using the test, it only covers these ones here because this is just a small example. If we use the attempt button, it's going to use the wider tests and see if any of them fail. There you go, it's all working fine, and this is covering 100 different tests. You can see there's lots of values are over 255, but our code covers for everything. So let's just have a little recap just so we understand what's going on before I close the video off. So at first, just a quick hex recap. So when we're going from hex to decimal, each column is going to be a multiple of 16. So the first column on the left is whatever this number is times by 16, added to whatever this number is times by 1. So in this case, because we have f is actually 15 because we can only process one single value inside a character, so we can use 0 to 9, and 10 to 15 is being represented by a to f, as shown here. So to figure out what ff means in a decimal number, we take this column and we know it's 15 because we just said 15 is f, and we times that by 16, which will give us 240, and we add that on to f, which is 15 again, times by 1, which is then 15, and we add them together and get 255. So that's how to go from hexadecimal to decimal. And to go the other way around, you just need to do the calculations in reverse order. You need to figure out the biggest one first, the multiple of 16, and then whatever remainders is going to be the multiple of 1. So if we do an integer division from 255 divided by 16, we get 15 point something, and then we truncate the rest and just get 15. And we know that 15 is equal to f, and then that will give us 240. So now if we do 255 modulus 16 and find the remainder out of this calculation, then we get 15 as well, which will give us back an f, and therefore we have double f. To make our code a lot better, we actually have a new numbers array, which will give us the values that we've got in the parameters. Once we've initialized that array, we actually specified an overload to the restrict range function, which will give us back two different ways of being able to use this function. One of them is a reference to an integer, and the other one is a reference to an int array. Using the integer, we'll process them one by one, so we can do as we have here. We can restrict them one by one, and that takes up 3 lines of code, but that will still work. And if we place them into an array, we can restrict the ranges all together in one simple function and store it back into the array. After that, instead of doing this long tedious line, we can actually pull these down into the for loop and make use of the fact that we can use numbers.length. We specify our string output and then simply just call the return pair with the number we're up to, which is exactly what this is doing, except this is doing it 3 times, and this is also doing it 3 times. And in this case, we're just typing it all out individually, and in the for loop's case, we're storing it all the output inside the output string variable and then returning it at the end. The restrict range is very helpful because, as I just showed you in the extra tests, we have lots of numbers that are over 255 and lots of numbers that are negatives as well, so you want to make sure you increase that, otherwise you won't pass all the tests. Returning the pair is just doing both of our calculations, the divide by for the integer division and the remainder to figure out the rest of the numbers, and we just do this together just to make our code a little bit simpler. If we didn't have that, then we'd have to have 2 calculations inside here, and it would make the code look a lot longer. This is a simple function, but because we have 3 pairs equaling 6 characters, then it's quite a nice function to use. This function returns us back the letter based on a given integer. You can make this into a switch statement if you want to, it's clearly up to you. It's quite simple, it just checks if the values are above 10 to 15, and if they are, it returns a respective character, and if they're not, it just returns back the current character. And the reason why I didn't just keep this as A is because this returns back a string. And that's impossible to do considering this is an integer, so we have to convert it to string, otherwise we'll get a syntax error as the function won't match the data type that we're trying to return here. I hope this video made sense. If you have any questions, jump on the Discord and ask me anything, or drop a comment below and I'll be happy to help. If you have any challenges that you're stuck on and you want me to solve, drop them below and I'll get back to you and make a video on it. Thanks for watching, I will see you in the next one. This video was made possible by my awesome Patreons DP Unique, Tominator and Buddy Woody 9. Thank you for your continued support. I have a C# Masterclass Udemy course coming up soon. Make sure you subscribe to the channel and join the Discord server for exclusive discounts and promotions.